right, so normally when I give a talk, I try to make it very interactive. So think of this as a lightning round for Jeopardy. I'm going to ask questions, and I'm hoping that the brave souls out there who know the answer will speak up. All right, so let's get started because we got 20 minutes, and I got a lot of information I want to get to you. Okay, good. All right, so let's first start with the definition of privacy. According to Google, it's the state or condition of being free from being observed or disturbed by other people. Now, I have a little bit different definition. I'm not really authority, but I consider it controlling the use, sharing, and exposing of your information about you that could be used against you. Now, legally, because I have a law degree, actually the definition of privacy is related to an objective, reasonable expectation of privacy in the thing that you have. Now, there are some exceptions, like the garbage that you put out on your lawn. Someone can go through it. You don't have any expectation of privacy in that. Or if there's a helicopter flying over your backyard and you're growing some herbs, there's no expectation of privacy. So let's talk about privacy from a historical standpoint. Now, I might be dating myself, but 30 years ago, privacy was explicitly opt-in. So does anyone remember what surveys are? I mean, you remember when you walk around a mall, there'd be someone with a clipboard, and they say, hey, can I ask you some questions? And you go, oh gosh, what are you gonna ask me now? And you could say no. Now, 15 years later, or actually 10 years to 15 years ago, the model for privacy became implicit. We had things like Gmail and search queries and browser tracking, but Google actually does some things to try to protect your privacy. Today, it's practically unavoidable. You got the tracking cookies, you got mobile apps getting your location everywhere you go, you got companies tracking what you click on, what you choose, what you buy, what you say. It's all recorded. And it's only going to get worse because of robotics and machine learning. So we're going to eventually be in a situation where it's a pervasive automatic opt-in, where everything that is perceived by the machine learning and by the robots is a potential for a privacy violation. So let's talk about machine learning. Machine learning needs a lot of data to make its predictions, right? To learn. And it has the potential to know you better than you know yourself. I mean, there's a lot of aspects about yourself that when you think about, sometimes you don't want to face, right? And based upon your behaviors, you can't run away from that. And when you think about machine learning, this is an important concept. I want you to think about how machine learning is going to process and understand the world around them. Can anyone tell me what is the major mechanism by which machine learning is going to understand the world around it? The data, but what kind of data? If it's observing things, cameras, right? So cameras are a big part of this. So today we're going to focus on some a little bit more advanced areas where privacy can be compromised, deep fakes, and I want you to think about cameras, all right? All right, machine learning is compute intensive, all right? So it means that if you have an edge device, like a microwave, where it's got a CPU with maybe, a very small amount of memory, right? It can't do machine learning. It doesn't have enough memory, it doesn't have CPU, so it's got to send everything to the cloud. So if you think of anything that's AI-enabled, for right now, except for maybe phones because they have new chips coming out, it's going to have to send whatever data that it gets to the cloud, okay? And it's going to be stored somewhere in some corporate environment, and that means that some corporate environment has your data, all right? Now, let's think about this whole thing with machine learning pervading all of our at-home devices and our environments at home. And there's actually a microwave oven that's recently come out that will look at your food and figure out what you're cooking, how long it should be cooked, and make food tastier, right? So another question, going back to what we've been talking about. If you AI enable your dishwasher, your refrigerator, or your oven, what are you going to need to do? What are you going to need to put in it? What sensor? We've been talking about it. Camera, right? All right. So this leads to another aspect of privacy violation. Legally, we call it using another person's name or likeliness. And there was something out of Samsung AI where basically they can take a single picture of you and then make it do and say anything. So that's just one picture they took, and they basically brought Marilyn Monroe back from the dead. And there are other examples, Salvador Dali and some of the other ones. I don't know if I'm going to really go through all these videos because I have 20 minutes and I want to give you an introduction to machine learning. All right, so now let's think about robotics. When you look at these pictures of robotics, what is the primary mechanism by which all these robots perceive the world? Cameras, right? Their eyes, the cameras. All right, so what does that mean? That information is going to go where? To the cloud, to some corporate environment. So when you look at that and you think about it, you got to ask yourself these questions. Who can look at this data? How is it used? And how is it protected? So let's talk about security. So robots have AI in them, and they also are interacting with the world, and they're physical. So that means you've got to have a large team with expertise in so many different areas: electronics, mechanics, AI, computer vision. There's so many areas that you have to have, hardware, software, to make it all work. And the problem is that to make it work, because you have all these different areas, security gets kind of put on the back burner. So this is an example of a robot being turned into Chucky, and I hope everybody understands what Chucky is, but if you watch the movies, you would see. Oh, is there any volume? Sorry, this is actually, if you could turn up the volume on this video. That actually sends shivers down my spine every time I hear that laugh. And I wasn't a big fan of Chucky, but you get the idea, right? So basically, two guys from IO Active hacked this robot because a robot has to communicate. It's connected to the internet, with the internet, and has all these interfaces on it, all right? So let's talk now about machine learning security, all right? There's two types of machine learning security. One, issues that are related to side effects of enabling machine learning on a particular device, and then there's direct attacks on machine learning, all right? So this picture here on the left was actually a picture of a microwave that had some kind of defect in it where it would turn itself on and it wouldn't shut off. Now, if you think about it, there's a lot of energy that goes inside of a microwave. And if there's nothing to absorb it, if you're not cooking it, if you're not cooking something, then that energy is going where? It's just building up inside that microwave, right? Until eventually it explodes. I mean, you don't even see the door on that thing, right? And so when you think about it, many different things that have machine learning, that have now interfaces to the internet, are going to be remotely enabled. So what happens is the product managers go, hey, we got this oven. It's connected to the internet. What can we do? Well, let's make this app where the user can see what's inside, like if they're cooking bread, and put the yeast in and put the dough in, and then when it's risen, what are they going to do? Remotely. Turn it on. Exactly. But then what else does that mean? If you've got people who are trying to put together an oven and make it work with the software and stuff, typically security is not a priority. And that's a problem. Because once you have these things in your home, and they can be remotely controlled, you have a pretty bad possibility of things happening, right? All right. So, To talk about the direct machine learning vulnerabilities, the direct attacks on machine learning, I have to give you an introduction to machine learning. How many people know machine learning here? Whoa, all right. Wow, okay. Well, for the people who don't, this will be like a quick 5 minutes, so just give me 5 minutes here. Machine learning and deep learning in particular came from this idea of these neurons. Okay, so if you look at the top left, I have 5 neurons, and there's a cell body with the nucleus, and there are 2 things going on in that neuron. The first is collecting all the impulses that are coming into it, and then second, making a decision on whether a threshold is met for the amount of impulses coming in to say, this is important, I need to forward this on and translate that pulse, okay? So there's a blue dot to signify the 2 things, the summing of all the things coming in, and then the translation of the output of the sum to some nonlinear output, okay? And that's a bunch of techno jargon. I apologize for that, but that's kind of what it is. All right, so if you look below the 5 neurons, there's a picture of a logical neuron that's from a neural network. And if you see it, it kind of looks like the neuron, right? You have the left side where the dendrites are receiving in the impulses through the fingers of the cell body, and then you have the 2 parts in the node, and then you go out and you stretch out. Now, if you take the 2 ends and you pull them together, you get what's over there in the top right, which is a representation for the blue nodes in that picture on the bottom right. Okay, so every one of those blue nodes is one of those over there on the top right. Everybody got that? Okay, and let's talk a little bit about the math behind it real quick, because I think it's important. When we say sum, what we're taking is an input numeric value multiplied by a weight value, and then adding it to the I2 times the W2. These are just numbers, and then 1 times the B1. We get our sum, we pass it to an activation output function, and then the output of that is multiplied by each of the connections that is connected to it to be summed up to the next layer nodes. All right? So if you look at that picture, the blue nodes, all that is happening in this AI, or machine learning, is just what? A mathematical set of operations that takes inputs as numbers, multiplies them by the weights, sums them up into the first node, inputs to the first layer, the blue layer, then runs it through an activation function, creates an output, and those values are multiplied by those connections in the second layer. The values are summed, and so on and so forth through the neural network until you get your output numbers. Okay? So if you're trying to classify things, if those 4 things were cat, dog, bird, car, then you'd want 1 to be on what the input was. So if it was a car, the car node would be 1, and everything else would be 0, right? So that's kind of how a neural network works. So the important thing I want you to understand is that there's no thinking involved there, right? There's no thought. There's no discernment. It is just a rote set of learned patterns that it's seen, and just a mathematical set of operations. Okay? All right. So, the one attack today I'm going to talk about is something called adversarial samples. So, can you see the difference between the first image on the left and the image on the right? Can you tell the difference? No, exactly. But a neural network can. And when you feed that image on the left, which hasn't been perturbed through the neural network, it comes out correctly tabby cat. But what you can do is you can use different methods to change every pixel a slight amount to increase the error of the prediction, or you can pick certain pixels that are known to adversely affect the error and focus on those and perturb them even more such that the output gets incorrectly evaluated. Okay? Does everybody understand the general principle of this? Remember, if I go back, a neural network is just taking every single pixel of the green nodes as an input and just doing a set of mathematical operations. And so if I take the original picture that works, but I perturb every single pixel in that cat image just slightly, where a human can't see it, but the neural network, because all it does is take those values as math and do the operations, all the small changes will aggregate to a large change in the output and thus result in a false classification. Does everybody understand that? A neural network doesn't do any thinking. It just does math, all right? All right, so how do we protect ourselves from, privacy violations? Well, it's going to be very difficult, but, one thing, and I'm probably telling you to violate your EULA, is you can put false information in your registration, right? Or, Google has some really nice things. They have takeout.google.com. If you haven't been there, you should go there, because it is eye-opening what they know about where you are, what you do, what queries you do, when, all that stuff is in there. You can also try to demand anonymous mode in your phones. I don't know if that's going to work, but and then there's the deep fakes, right? How do we protect ourselves against those? And today I'd like to talk about a technique that is based upon this idea in Eastern medicine of using a poison to fight a poison. But first, let's talk about some physical measures that we can put in place on our phones today that will make it help give you notice that a picture that's being taken can be used in a deepfake. So ideally, you'd like to have this special LED on the camera where if they were taking a picture of you where they could use it to make a deepfake, it would turn red, right? And if they took a picture of you where we added some stuff to it where it made it very difficult for the person to create a deepfake, it would be green. Okay? And now let's apply what we learned about adversarial samples, okay? So if the deep fake looks at a face and looks for these markers, like where your chin starts or where the end of your lips are, where your nose starts, where the tip of the nose is, where the eyes are, where the different parts of your cheekbone are. And if we apply the same technique to change a face into guacamole, meaning when it gets through the neural network, it goes, what the heck? Well, the deep fake that would be produced from that face would be very warped, right? So we can use this technique to fight deep fakes. The other thing is trustworthy security. So, today we're kind of trusting the vendors to say, yeah, we did, assessment, we did our security, blah, blah, blah. But actually things are moving toward a direction where we need more proof. We need more assertions of actual security being implemented in these type of sensitive products. And there's more information there. Some of my friends in MITRE have been pushing this through, and I really like it. And then finally, the company I'm working at is doing research on these types of attacks in machine learning and deep fakes and coming up with different protection mechanisms. So thank you very much.